So here we have a racing car which is accelerating uniformly from rest along a straight track. So initial speed is 0. The track has markers at equal distances as shown. The car crosses marker 2 at a speed of 140 kilometers per hour. And the question is, at what part of the track would the car be traveling at an instantaneous speed of 70? So a very interesting question. There are two ways of solving this question. The first approach is using a lot of equations, which of course takes a lot of time, but there is a smarter way, and that is by using graphs. So we are going to discuss both methods. Method number one will be the shorter graph method, and method number two will be the equations method, which is important for you to go through just for the sake of revision. So let us start with method number one. So let us write down all the information which is given to us currently. It is saying the racing car is accelerating uniformly. So uniform acceleration is there. Initial speed is 0. And then the question has specified that the track has markers at equal distance. So now if I show from the start till the marker 1, let's say the distance be d. Then the distance from marker 1 to marker 2 will also be the same. That will also be equal to d. And now you can deduce from this figure that the car has traveled a total distance of 2d when the car is crossing marker 2. Initial speed is u, final speed is given 140, and the distance we have deduced to be 2d. So we are going to use an equation which has all these parameters, which will be v square is equal to u square plus 2as. Initial speed is 0, so we will write that down, 0 plus 2 into acceleration. Acceleration is uniform multiplied by the distance traveled. And let us write the value of s as x. And now we can simplify this equation to become v square is equal to 2ax. And if we try to make v, velocity, as the subject, we will write square root of 2 into a into x. Now the approach here is we have to draw a graph between the velocity and the displacement x. So let's say this is the graph. Y-axis will be the velocity v and the x-axis will be the displacement. Let's write x in this case. Okay, now this will be maths. If the equation looks like this, how does the graph look like? So v, velocity, is on the y-axis and x, the displacement, is on the x-axis. So this equation is of the form k into root x, where k is a constant. The constant in this case will be root 2a. And please note, whenever the equation looks like this, y is equal to k root x, the graph will be a parabola, but a downward facing parabola like this. And now we can analyze the graph with respect to the image. At the start, the speed of the car is 0. That is why the graph is starting from the origin. Let's draw the origin is 0, 0. When the car reached marker 2, which means it traveled a total distance of 2d, the velocity was 140. So in the graph, let us label, let's say the displacement value is 2d. In that case, the velocity of the car as given in the question will be 140. Now, if I go back to the question, they want us to find at what part of the track is the car traveling at a speed of 70. Now coming back to the graph, 70 is half of this 140. So let us mark 70 at the midpoint over here. And if I draw a dotted line so that it touches the graph, and then we draw a dotted line to go on the displacement axis. So this is the value of x which we require. Now if we go back to the options, option 1 is before the marker 1, option 2 is at the marker 1, and so on. And now going back to the graph, if 2d was the total displacement at marker 2, so d is the distance traveled by the car when it is crossing marker 1. Mark the midpoint of 2d over here. So total distance was 2d. So small d will be over here. So let's write down d. From this figure, you can clearly deduce that the value of x which we require is clearly less than d. So let's write the value of x will be less than d. And what is x? X is the distance traveled by the car when the car is traveling at a speed of 70 kilometers per hour. And since x is less than d, so the car will be somewhere before the marker 1, since the distance traveled is less than d. And that is why we can say option number 1 is the correct answer. Now, this method, although a little tricky to understand, it is the fastest way to solve the question in an exam scenario. But let's say for whatever reason, this method doesn't click in the exam scenario, then we can always stick to the basic equations. And even that method is not that difficult. So let's see. So in method number 2, we are indeed going to use the same formula v square is equal to u square plus 2as, keeping in mind the distance between the start and the marker 1 is equal to the distance between the marker 1 and marker 2, since the question had specified that the track has markers at equal distances. So consider the situation 1. When the car was traveling at a speed of 140, when it has traveled a total distance of 2d. So final velocity we will write as 140 squared, initial velocity is 0, plus 2 times the acceleration, let's say, is a, and the distance traveled will be 2d. So let's write down multiplied by 2d. And if we simplify this expression, we'll get 140 square will become 4ad, and let us try to make a into d as the subject. So we will get 140 square divided by 4. So this is situation number 1. Situation number 2 is we need to find the value of s, the displacement, when the car was traveling at a speed of 70 kilometers per hour. So instead of the final velocity, we'll write 70. Initial velocity is 0, acceleration is a, and the distance traveled we don't know, so we will write that as x. And in this case, let's simplify. 70 square will come out as 2 into a into x, and if we try to make x as the subject, since we are supposed to find x will come out as 70 square divided by 2a. Now the question has not given us the value of acceleration, but we had earlier deduced that a into d was this 140 square by 4. From this expression, let us try to make a as the subject. So we'll get 140 square divided by 4d as the value of acceleration, which can be put in our final expression. So let's continue simplifying this. The value of x will come out as 70 square divided by 2 multiplied by acceleration was 140 squared divided by 4d. So 140 square will write here, and the 4d will go in the numerator. And let's simplify this. 2 will get cancelled, 2 2s are 4. So the value of x will come out as 70 squared divided by 140 squared multiplied by 2d. And let us try to simplify as much as possible. So we can write the square 70 and 140 like this. So 70 divided by 140 whole squared multiplied by 2d. Now 140 is a multiple of 70. So 70 ones are 70 twos are. So we'll get 1 upon 2 multiplied by squared multiplied by 2d, and let's simplify this. We'll get 1 upon 4 into 2d, which comes out as d by 2. Hence, we can finally write that the value of x is equal to d by 2. And let's try to recall what is x. X was the value of the displacement traveled by the car when the car was traveling at a speed of 70. Now, going back to the question, we were supposed to find at which point of the track is the car traveling at a speed of 70. So the car is actually in the midpoint between the start and the marker point. So if I label between start and marker, this is that point where the speed of the car is 70 kilometers per hour. And finally, we can say option 1 is the right answer to this question. So this was the second method using the equation. So in the exam scenario, whichever method clicks and you find it easier, we can use either approach. Method 1 was the graph-based approach, and method number 2 we just saw is using the equations.